The exponential function that we learned in last class has a partner function that we are going to be learning about today. And together we are eventually going to be using both of these to solve equations. So today's function that we are talking about is what's called a logarithmic function. Now, you won't hear me use the word logarithmic. Usually you will hear it referred to simply as a log function, L-O-G. So the proper way that we are going to be using these, this is called the logarithm of y with base b. Okay, this is the symbol notation that you will be seeing throughout this lesson. Yes, this is a long, lengthy phrase, the logarithm of y with base b. For our class, the simple way that I would expect you to read this to me so that we are communicating properly is log base b of y. If you can remember that phrase, log base b of y, that's all I expect you to be able to use for communication purposes. Now there's two forms of these logs that we're going to be using today, and we're going to be practicing swapping between the two forms. The first form is the new form that we were just talking about, and that is the log form. So the log form looks like exactly what we were just saying. Log base b of y equals x. The other form, the exponential form that we need to be familiar with, looks like this. B to the power of x equals y. Now we have to be able to swap between these two forms very easily. And some people are just good at memorizing how they look, but I'm going to show you a little trick. I call it my circle that will help you swap between the two. If you are given log form, which is this form, and you want to change to exponent form, I'm going to connect the three variables in the equation with a circle. I always start my circle at the base, and the base is b. So I'm going to go in a circle this way. My circle is going to come over here to x, and then I'm going to keep going around my circle, and it's going to end right here with y. Now, no, it's not a perfect circle, but it is a circular shape. The reason I connected them in this order is this is the order that you are going to write them in exponential form. B to the power of x equals y. It's exactly what we have written down here. So if you can remember this circle, it will help you in changing from log form to exponent form. And just remember, when we are changing, we're getting rid of the word log. Now, the same thing actually works with exponential form. If I make a circle, and my circle again always starts at the base, I go from the base, I start my circle, which leads me over to y, I continue my circle, which leads me over to x. That's the order that you will write the variables when you're going back to log form. Yes, you have to remember to add the word log, but then it's log base b of y equals x. Log base b of y equals x. So this circle, it just keeps you organized so that you're making sure when you're converting forms, you're writing the variables in the correct order. So we're going to practice this circle and just swapping back and forth between the two forms for a couple of examples. So as you can see at the bottom of your page, the first example says, write these in exponential form. Okay, so remember, exponential form means no log. So I'm going to use that circle we were just talking about. Where do I start? I start at my base. That's the little guy. 3 circles over here to 2, which circles back over here to 9. There's my circle. So in exponential form, it's 3 to the power of 2 equals 9. And by the way, this should be a true statement. Is 3 squared equal to 9? Yes. If you type in your calculator 3 squared, you do get 9. That's another way you know you did it correct. So pause the video for a second and try these next two and see if you can convert them to exponential form by yourself. Okay, so let's see how you did. So if we follow the circle, it will be 8 to the power of 0 equals 1. 8 to the power of 0 equals 1. And yes, you can verify this in your calculator. 8 to the power of 0, your calculator will tell you is 1. Hopefully you did this one correctly. 5, circling over here to the power of -2, circling back over here equals 1 over 25. 5 to the power of -2 equals 1 divided by 25. If you type this in your calculator and you hit math, enter, enter, you will get 1 over 25. So hopefully those aren't too bad. That's going one direction. You have some of these in your homework. Let's go the other direction. Write in log form. So when you are writing in log form, now you actually are putting in the word log. Before we were taking the word log out, now we're putting the word log in. So remember, it's always going to start with the word log, but the circle helps us remember the order of the rest of them. So if we start our circle at the base, which is 3, 3 circles over to 9, 9 circles over to 2. So of course the first thing we write down is log. So it's log. Now after log comes the base. Base 3 of 9 equals 2. So that's how we go back to log form. Let's try the next one together. Start our circle. 2 circles to 1/2, which circles back over here to -1. First thing we write down is log. Log base 2 of 1/2 equals -1. So just remember, with logs, the base is a subscript. Okay, now you guys know what superscripts are. Those are the ones at the top. Those are your exponents. This is a subscript. This is a little number. This is a regular size number, and that's a regular size number. Little number, regular size, regular size. So pause the video and see how you do with these two. So let's see how you did. So we're going to start our circle always here at the base. Circle over to 16. Back over to -2. Start with the word log. Log base 1/4. Yes, it's okay to have a fraction down there. Of 16 equals -2. On this one, start with the 8. Circle over to the 4. Circle back over to the 2/3. Start with log. Base 8 of 4 equals 2/3. So that is one skill that you're going to have to be able to do today for your homework, is swapping between the two forms. So let's look at a couple of definitions. These are very, very special and important buttons on our calculator. The first one is called the common logarithm. So the common logarithm, which is the log that we use most often, is a log with a base of 10. So log base of 10. And then it doesn't matter what letter is there. It's just a placeholder. Log base 10 of x. Now the thing is, when we actually see it on paper, you're not going to see it written log base 10 of x. You're simply going to see it written as log x. Okay, 10, the 10 is automatically imaginary. So if you see this anywhere on your paper, you know there's automatically an imaginary 10 right there. The other log that's important to us is what's referred to as the natural log. The natural log is a log with the base of e. Log base e of x. And if you remember this guy, we learned about him last lesson. He was that letter that is a set number, never changes, like pi. Okay, so yes, I know it's a letter, but it's really not. It's really a number. Now the thing is, again, you won't see this written on your paper either. When you have a log and its base is e, we write it using the notation ln x. ln stands for natural log. Yes, that's an L, it is not an I. So anytime you see this guy, ln of x, you know it's log with a base of e. Now the reason these two logs are so important to us is because they are used most often. And because they are used most often, they are programmed onto your calculator. So if you take a look at the calculator for a moment, okay, if you look over here on the left-hand side, right here, there are those two important buttons. This log button here is programmed to be with your base 10. Okay, when you press that button, it is automatically base 10 and nothing else. This one here, that's your natural log. That's the one with the E. You have no control over changing these buttons. They are programmed into the computer like they are programmed into the calculator like a computer. So as much as you would like to change it to a different number, you can't. So we're going to practice using those buttons. We have 3 problems here. We're simply asked to evaluate to 4 decimal places. And so this first one, log of 7, all we're going to do is we're going to press the regular log button. We're going to put in the number 7, close parentheses, there's our decimal. And yes, I said 4 decimal places. So 0.845, and this 0, because of this number right here, rounds up to a 1. 0.8451. 0.8451. Pretty easy. So, pause the video, try both of these. Just pay attention to which button you are pressing on the calculator. Okay, so let's see how you did. Natural log 0.25. So natural log 0.25 plus parentheses, we get negative 1.386, and this, because of the 9, rounds up to a 3. Negative 1.3863. And this last one, you're going to press the log button, and then negative 4.2. Log button, negative 4.2, and your calculator tells you you have an error. No, you did not make a mistake. Okay, this one is not possible. Let's talk about why. Logs don't like certain numbers. So if you want to jot this down, this would be worth jotting down. Logs don't like negative or the number 0. So no negative numbers and no 0. Okay, it doesn't matter what number it is. You can try as many as you want. Okay, if you try the log of negative 1, doesn't like it. If you try the log of 0, doesn't like it. Okay, so keep in mind, no negatives and no zeros are allowed to be with logs. So let's look at our next vocab word. Now this is a very important vocab word to us. Okay, this is the change of base formula. As we were just discussing on the previous slide, the calculator only has 2 log buttons. The first one has a log with a base of 10, and the second one is ln, and that was log with a base of e. Any other base that exists out there cannot be put into the calculator until now. The change of base formula allows you to type any log into the calculator. So if you are given something that looks like this, log base b of x, we're going to change it into a division problem with two logs, both base 10. So log of x, so this part goes on top, divided by log of b. So remember, the base goes on the bottom. Base, bottom. But these are both now, because remember we talked about if there's no base there, it's an imaginary 10. These are both base 10s, which means we can use the calculator. So let me show you how this very nicely works. We cannot type this in the calculator right now. We're going to apply this formula. We're going to have a division problem. Your log on the top is this big number. And remember, your base of 4 is with your log on the bottom. Base on bottom. So we turned it into a division problem. Two logs, the base is on the bottom. You could type it in. The one thing that's important, your calculator does that automatic parenthesis thing. When it opens a parenthesis, you have to remember to close it. So let me show you what I mean. Let's get rid of all this. Log 64. Close those parentheses. Otherwise, you'll get a wrong answer. Divided by log 4. Close. It's typed incorrectly. The correct answer is 3. Now, not all of them will come out to be whole numbers. If you don't get a whole number, round to 4 decimals like what we were just talking about on the previous example. So we're going to do one more together, then you're going to try one on your own. So division problem. 2 logs, base on bottom, other guy on top. So we'll type that in. Log 15, close parentheses, divided by log 2, close parentheses, 3.906, and this guy rounds him up to a 9. So 3.9069. So go ahead, pause the video, try the next two to make sure you're able to do these on your own. Alrighty, so let's see how you did. This one you should have changed to log 50 divided by log 1/4. And if you typed it in the calculator correctly, you should have gotten negative 2.8219. This one you should have written as log 2 divided by log 32. And if you typed it in the calculator correctly, you should have gotten 0.2 exactly. So this change of base formula is probably the most helpful formula you've learned today. And we're going to continue to use it because one of the things that we're going to practice is graphing. That's the last thing on the agenda today. Now we're going to start graphing these the exact same way we started graphing last lesson. We want to know, what does the general pictures look like? So as you can see, we have a table here that we are going to be filling in. Now in order to use the calculator, because of course this little 2 here, calculator doesn't like it, we're going to start by using the change of base formula. So this is going to be rewritten as a fraction with 2 logs. Sorry, there we go. The base of 2 is on the bottom, the x is on top. So this is going to help us with the calculator part of it. Now that we have it so that we can actually use our calculator, we're going to plug each one of these numbers into this x spot right here. Now yes, I know it kind of seems like a strange selection of numbers. I did it for a reason. Just watch and we'll find out. So let's start with negative 1. So you're going to type in your calculator log negative 1 divided by log 2. So we'll just show you 1 again. Log negative 1 close parentheses divided by log 2. Your calculator tells you error. We talked about that, don't you remember? Logs don't like negatives. So we're just going to write error here and we're going to move on. Well, you should be thinking to yourself, wait a minute, Miss Simon said the logs don't like negatives or zeros. You're going to get an error here as well. Okay, with logs, we can't have those negatives or zeros. So let's see if we can find some answers that do work. So we're doing 0.25. So pick up your calculators. Log 0.25, close parentheses, divided by log 2. Hopefully, your calculator told you negative 2. Let's do one more together. Log 0.5, close parentheses, divided by log 2. Hopefully this time your calculator told you negative 1. Go ahead and pause and finish these 4 real quick. Finish filling in that table. So how did you do? You should have gotten, for 1, when you typed in log of 1 divided by log of 2, you should have gotten 0. When you typed in log of 2 divided by log of 2, you should have gotten a 1. When you typed in log of 4 divided by log of 2, you should have gotten a 2. And when you typed in log of 8 divided by log of 2, you should have gotten a 3. So let's see what kind of shape this makes. So we're going to go to the right, 0.25 down 2. So right just a little bit, down 2. Then we're going to go right a half a box and down 1. So right a half a box, down 1. Then we're going to go right 1 and stay there. Right 1, stay. Then we're going to go right 2 and up 1. Right 2, up 1. Right 4, up 2. Right 4, up 2. Right 8, up 3. 1, 2, 3, 4, 5, 6, 7, 8, up 3. So what do you see here? You see a curve. So if we just connect the dots, we know we have this kind of curve going like that. Well, hopefully you should be thinking, well, I know this is going to keep going this way. It is. You can put the arrow there. It's going to keep going that way. But what's going on here? Okay, we've just learned that we can't plug in 0. So you're never going to actually get to 0. If you remember, last lesson we talked about asymptotes and imaginary lines that we can't touch. We have this going on again. The difference is we're going to go down, 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 and we're never going to touch the y-axis. So now you have an asymptote again. This time your asymptote is the y-axis, not the x-axis. It's vertical. So let's take a look at the next one so that we can get an idea for what this equation is going to look like. So again, change of base formula just like we did on the first one. 2 logs, base goes on the bottom. That means x goes on the top. So let's think about this quick. We just learned the logs don't like -1 and 0. So of course, these are both errors. So let's start with the number that we know the calculator will like. Pick up your calculator. Log 0.25, close parentheses, divided by log 1/2. If you do that correctly, your calculator should tell you 2. Next one, log 0.5, close parentheses, divided by log of 1/2. You do that one correctly, your calculator should tell you 1. Go ahead and pause the video and finish these 4 real quick. So for this one, log of 1 divided by 1/2 is 0. Log of 2 divided by log of 1/2, you should have gotten -1. Log of 4 divided by log of 1/2, you should have gotten -2. And log of 8 divided by log of 1/2, you should have gotten -3. So let's see what this graph looks like. We're going to go right 0.25 up 2. So right just a little bit up 2. We're going to go right 1/2 and up 1. So right half a box, up 1. We're going to go right 1 and stay there. We're going to go right 2 and down 1. Right 2, down 1. Right 4, down 2. Right 4, down 2. And right 8, down 3. 1, 2, 3, 4, 5, 6, 7, 8, down 3. So does this look similar to what we just drew? Yes. We're going to connect our dots, and if you notice this time, they're going in a downward direction. Yes, you're going to keep going that direction. Yes, you're going to keep going up, 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 up. So these are similar graphs. If you take this one and you reflect it, you get this one. So this one also still has an asymptote. And yes, the asymptote is still the y-axis. So how do we know which graph we're going to be looking at? This has to do with the base. If you notice this one, the base was 2. When the base is greater than 1, you're always going to have this slowly going up to that way. So you're going to go up, 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 and then curve to the right. When your base is between 0 and 1, which is what we have here, we have a fraction, you're going to go down, 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 and then curve to the right. Both of them are curved to the right. It's just, are you going up, 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 and then curving, or down, 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 and curving? So let's take a look at how we're going to apply this to all of our graphs today. These are very similar steps that we saw last lesson. You're going to use your base equation, which stops with x, y equals log base b of x, and you're going to use the change of base formula like we just did to fill in the table with only 3 x values. The x values we are always going to use are 0.5, 1, and 2. Once you fill in your table, graph the 3 points. Remember, you have your asymptote. Once you are done with the 3 points, now you are ready to shift your 3 points. We're going to add in 2 pieces of shifting information. We're going to add in a C inside the parentheses and a D outside of the parentheses. So the rules for the C, and again this is inside your parentheses, same rules you've seen 3 or 4 times now. This is going to move your graph left or right. If it's positive C, it goes left. If it's negative C, it goes right. That's the opposite one. With your plus D, this moves your graph up or down. If it's a plus C, you move up. If it's a minus C, you move down. We've seen these rules now for 3 other graphs. So hopefully by now you've kind of gotten used to them. Now here's our important note. If the graph shifts right or left, the asymptote must also shift. Whoa, that should not say up or down. That should say right or left. Fix that on your paper. Nope, it's right on your paper, it's wrong on mine. So remember, now it's the left or right that's going to affect your asymptote. The day before, it was your up or down. Now it's your right or left. So let's try, we have 3 examples. We're going to try 2 together, and you'll try 1 on your own. You're being asked to graph y equals log base 4 of x plus 2. First thing we like to do, establish that base equation. Remember, your base equation stops at x. Y equals log base 4 of x. No need for the parentheses right now. So there's your base equation. As our direction said, you need to use the change of base formula. So 2 logs, the base of 4 goes on the bottom, the x goes on the top. So pick up your calculators. Log 0.5 close parentheses divided by log of 4. You should get negative 0.5. Log 1 close parentheses divided by log 4. You should get 0. Log 2 close parentheses divided by log 4. You should get positive 0.5. So there's your 3 dots. So let's graph them like the first instruction said. Right a half, down a half. Right a half, down a half. Yes, you're kind of floating in the middle of space. Right 1, stay there. Right 1, stay there. Right 2, up a half. Right 2, up half. So which direction are these points going? Are they going up or are they going down? These are going up. So this is where we're going to go up, 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 connect, curve to the right. Once you connect them, you start curving to the right. And notice I didn't touch my y-axis because that's my asymptote. So now, if we look at our next step, this is our shifting stuff. So we have 1 number to shift. We have this guy right here. Well, that number is inside the parentheses. So when it is inside the parentheses, it is C. And since it is plus 2, it moves it left 2. So we're going to make a note, this guy right here, left 2. So I'm going to take all 3 dots and go left 2. 1, 2. Notice I stayed in the middle of a box. 1, 2. 1, 2. Don't change its location, just shift it. Now don't draw in your dots yet, because we have to shift. If we shifted left or right, which we did, the asymptote must also shift right or left. So I'm going to take my asymptote that was right here, and I'm going to go 1, 2 to the left. So I'm going to put my dashed line right here, left 2. So now you can go back and go up, 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 hit my dots, curve, 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 curve to the right. Up, 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 curve, curve, curve to the right. So not too bad. Let's try the next one together. So same thing, starting with our base equation. Y equals log base 1/4 of x. Base equation done. Change of base formula. 2 logs, 1 on the bottom, 1 on the top. Base goes on the bottom. X goes on the top. Pick up your calculators. Log 0.5 close parentheses divided by log 1/4 close parentheses. You should get 0.5. Next one, log of 1, close parentheses, divided by log of 1/4. You should get 0. Last one in your calculator. Log 2, close parentheses, divided by log of 1/4. And you should get negative 0.5. So there's our 3 points that we are now going to graph. Right half, up half. Right half, up half. Floating in space. Right 1, stay put. Right 1, stay put. Right 2, down a half. Right 2, down a half. So are these points going up or going down? This time they are going down. So I'm going to start here and I'm going to go down, 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 down. There's my points. Now I'm going to start curve, 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 curve to the right. As soon as I hit my points, I start curving. So down, 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 hit my points, curve, 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 curve to the right. Don't touch the y-axis. Now let's talk about our extra number. We have this little +3 right here. Is it inside or outside the parentheses? Well, since there is no parentheses, we have to assume it's outside. So if it is outside the parentheses, it is D. So a +3 would make it move up 3. So this number is going to make it go up 3. So take this dot and go up 3. Notice I stayed in the middle of my box. This dot, up 3. This dot, in the middle, up 3. Now, did we move left or right? And the answer is no. So the asymptote doesn't move. You are still not allowed to touch the y-axis. So we're going to follow the same red path we did before. Down, 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 down. There's my dots. Curve, 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 curve. Remember, down, down, down. Hit your dots. Curve, curve, curve. So now you're going to pause the video and you're going to try this one completely on your own. Okay, so let's see how you did to finish. So your base equation was y equals log base 2 of x, and your change of base formula looked like log x divided by log 2. When you plugged your 3 data values in, you should have gotten a -1, a 0, and a 1. When you graphed them, you should have gone right half, down 1, which is right there. You should have gone right 1 and stayed put, right 1. You should have gone right 2 and up 1. So as we can see, this is an up, up, up problem. So we're going to start at the bottom and we're going to go up, 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 up. Hit our dots, curve, 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 curve to the right. So hopefully you had the parent correct. And then you have 2 numbers to shift. You have a -1 and a -4. So -1 inside should have made your graph go right 1. And a -4 outside should have made your graph go down 4. So we're going to take each dot and go right 1 and down 4. Starting here, right 1. 1, 2, 3, down 4. There, right 1, 1, 2, 3, 4. Here, right 1, 1, 2, 3, 4. Our asymptote only goes with the left and right. So our asymptote also goes right 1. So instead of the y-axis, we're going right 1, so it is right here. Yes, it's going to kind of touch the old graph, and that is okay. So then go back, trace your new asymptote, up, 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 up. There's my dots, curve, 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 curve. And you are done.